Good day, my name is Marcelo de Lima Galvão, and in this video I will present the paper BeeAR, Augmented Reality Beeline Navigation for Spatial Knowledge Acquisition. This paper is authored by Bartosz Mazurkiewicz, myself and Professor Ioannis Giannopoulos from the Department of Geodesy and Geoinformation at the Technical University of Vienna. In this paper, we present an evaluated navigation system for pedestrians that combines augmented reality and beeline navigation. In these navigation systems, the location of the destination is overlaid with a digital landmark which is permanently displayed to the users. The motivation of this paper is to stimulate free choice for pedestrians at decision points. So we are looking for navigation approaches that do not impose a predefined route to the users. Although there is no need of matching between the digital map and the physical world. Furthermore, we have found evidence for poor spatial knowledge acquisitions using the current turn-by-turn approach navigations. And our hypothesis is that make your own turn decisions, you increase your engagement with the environment, leading to an increased acquisition of spatial knowledge. I would like to highlight some contributions of this paper. To the best of our knowledge, head-mounted augmented reality has not yet been combined with beeline navigation to scrutinize spatial knowledge acquisitions. This is different from other evaluated AR-based navigation methods, which normally uses arrows or indicators floating around the users to convey the direction of the destinations. Our BeeAR approach overlay the destinations with digital landmarks, so the destination is always visible to the users and the users can always know the correct directions. Furthermore, while the user moves, the digital landmarks respect its natural perspective view changes, apparent size, and relative motions. This local presence of the digital landmark that has natural space and motions will help the users understand their distance and spatial relations. Therefore, digital landmarks can be used as orientation anchors and survey knowledge acquisitions during the navigations. How do we evaluate the systems? We basically compare BeeAR with findings from a previous study that compares the turn-by-turn approach, which is the state-of-art used in smartphone, and an alternative navigation approach called free choice navigations that also aims to give freedom to the users. I'd like to highlight some difference between the three approaches that you are evaluating. First, you have the turn-by-turn approach, which is the state-of-art. It has a map with GPS indicators visible to the users. The route is defined on the map, and the user needs to passively follow the turn-by-turn instructions. The free choice navigation, in this case the user does not have a map, he walks hands-free. He knows only at the beginning the direction and distance of the destinations. Occasionally, if the user takes a very wrong way, he might get instructions to correct his path. The BeeAR approach, also the user does not have a map, walks hands-free, and the destination is constantly visible to the users. The user also has to make all decisions at the turns. So the experimental designs have the three conditions: BeeAR, turn-by-turn, and free choice navigations. It's a between subject study, having total of 16 participants in each conditions, and we evaluate the navigation approach in two different routes. The procedure consists of three parts. The first part is the online part, where I have the informed consents, you collect demographic data, and you check if the participants not familiar with the experiment area. Then comes the navigation itself. So we assign a route to the participants, and you do the calibration of the AR device to make it geographic aware, and you give the device to the participants to walk to the destination. After the navigation, the participants needs to do a series of spatial learning tasks and answer some questionnaires. Let's have a look on them. The spatial knowledge acquisition tests are the following. It's a pointing tasks, point to the destinations. You ask the participants to estimate the walk distance. You ask the participants to draw a sketch of the walked route. And after you ask the participants to retrace the routes on a street map. And finally, the participants are asked to recall and point in the map all landmarks or points of interest if remembered from the navigations. The questionnaires are the following: are the NASA task load index, it's the system usability scale, and the user experience questionnaire. Now I'd like to discuss your main findings. In this table in the right you have some variables that you were measuring. Let's start with the walking distance. You normalize the walking distance according to the shortest path, and the only finding that you have here is that turn-by-turn participants walked shorter routes compared to the free choice one. You didn't find any significant difference between turn-by-turn and BeeAR. Regarding the pointing tasks, the error for the BeeAR was lower, but as you can see, the standard deviation is pretty high, therefore those results are also inconclusive. The route retracing, the BeeAR users performed very well. 15 out of 16 were able to perfectly retrace the walked routes, and this result was significant compared to the free choice navigation participants. Regarding the recall of points of interest and landmarks, as well, the BeeAR participants performed very well, were able to significantly recall more landmarks compared to the free choice navigation users. Now the latent data question, the system usability scale questionnaire. The scores were very similar among all conditions. The user experience questionnaires, the results that you find regarding the BeeAR is a bit as expected. The users found the system very stimulating and very novel. Regarding the NASA TLX, the results are inconclusive but somehow interesting. Let's have a look. So the NASA divides the results in 6 dimensions: mental demand, physical demand, temporal demand, effort, performance, and frustrations. As you can see here, you have a good indications that the task load and the effort of the BeeAR participants were quite low, but still have very large error margins. This requires more investigation to be more conclusive. Finally, I'd like to point some directions for future work. You want to investigate it. How can you improve the digital landmarks, distance perceptions, and compositions with the physical environment to make them look more naturally and improve the usability of the system? As well, we are interested in understanding the virtual character of the landmarks in the context of AR navigations and their influence on spatial knowledge acquisitions. Finally, we want to explore how the augmented reality contents in the context of navigation can be used as orientation anchors or support for survey knowledge acquisition or spatial knowledge acquisitions. I hope if you find this paper interesting, I'm very happy to discuss it on the MobileHCI conference in Greece, Athens. Thank you very much.